So there you have my affiliation. So I have two hats. One is industry in Silicon Valley, and the other one is in academia in Europe and South America. And basically, this is a different way to say how to do responsible AI. So I will provoke you with some questions, and then maybe we can discuss every set of questions, because really there are more than 10. And this was based in an article I wrote in the Forbes Technology Forum in 2021, but have been upgraded with different new things happening. So before talking about the questions, let me talk about what is not responsible AI, because some people use other terms that I don't like. That's why I have this slide. So a lot of people use ethical AI, even research people. And I don't like that, because ethics is a human characteristic, and we shouldn't use human traits for algorithms or machines. And the same happens not only with ethics, but also with justice, with trust. In some sense, trust is binary. You never say, I have trust a person. It would be very weird to say that. I either do the benefit of the trust or not. And then, because of that, we shouldn't use these words for machines. The same happens when we go to generative AI, when we use a lot of things that are very human, like thinking, reading, writing, seeing. I will get back to that, because I think those words also shouldn't be used with chatbots. A lot of people in the US and in Europe use trustworthy AI. There are some research programs called trustworthy AI. But there are also issues with trustworthy AI. One thing is that we know that doesn't work all the time. Let's say you have an accuracy of 90%. So why we say it's trustworthy if we know that it fails? But also puts the burden in the user, not on the creator. Responsible AI is also, in some sense, responsibility is also human. But when I say responsible AI, I'm using responsible in the legal sense. So someone should be responsible of putting a product in the market, and that is the company putting the product. So, for example, if ChatGPT does something, does some harm, well, OpenAI is the responsible company behind that. So at least responsible AI puts the burden on the builder. Other people use AI ethics. That's correct. That's much better than ethical AI. You can use AI safety. Yes, that's fine. But I think a responsible AI goes beyond AI safety. It's more than that. It's not only safety, it's also to be accountable of what will happen. And the last topic here is that we humanize these technologies using these human words. For example, some people give names to chatbots. Some people talk about chatbots about a he or a she. Some people have digital friends that are chatbots, and they believe that they understand everything they say, and so on. So I will get back to this, but we shouldn't humanize these technologies. And I prefer the word humanize because it's not about the shape, anthropomorphize, it's about the shape. It's more beyond that, it's beyond robots. It's also when you interact with chatbots and similar tools. So this is the motivation. And just to make sure that you don't misinterpret me, I want AI system, so I'm not against AI, but I want this AI system to be legitimate and well implemented. And you will see why I like to use these two words. Okay, so I was one of the two main authors of the new principles for responsible remix systems that were published in October 2022. In fact, they were published like a bit more than a month before ChatGPT 3.5, the first like public version of that tool. And it was a pity because we were not thinking generative AI at that time, and we had to extend these principles to that. But here there are three principles that are new, that are very important. The number one, I push it. It's called legitimacy and competence. That's why I said I want tools to be legitimate. And legitimacy is about being ethical, the usage being ethical, being legal, so compliance. For example, have scientific basis, a lot of pseudoscience, and we'll get back to that. And then we have all the competences to do it well. So for example, we have technical competency, we have the domain competency of the application, and very important, we have the administrative competency. So we have the permission to do it. In many cases, in some of the examples I will show, the person that did it didn't have the permission to do it, but they never asked. The second one is also new, is like making sure that you minimize harm. So we put it explicitly, minimize harm. But when in Europe they saw this list only up to 8, they say, well, you know, when the people read minimize harm, they only think in people, they never think in the planet. So let's put something explicit about the environmental impact. And we added number 9, this one at the end. But these ones are also in the right order. Before, people don't worry too much about the order. I think the order is very important. I will show you why later. But all the others are basically very standard. You will see it in many other proposals. Now, when we had generative AI, we had to extend this to add 5 new principles: limits and guidance on deployment and use, ownership, personal data control, and correctability. This came directly from the impact of generative AI. Now, with this, we can have a very simple AI governance of responsible AI, adding also generative AI. So here are the same principles in order. And this is why the order is so important. You have, let's say you have the idea, and the first thing you need to do is a risk impact assessment. I hope you don't hear the noise. 1 second. Sorry, there's a bit noise. I will continue now. Okay, so you have an idea and you do risk impact assessment. So you think about all the possible risks and what will be the impact. So risk is thinking about what is the probability of something happening, and the impact means how many people or other kinds of impacts you will suffer. This is similar to what you do when you have a new infrastructure project, and then you do like a risk impact assessment on the environment, but here it's not only the environment, it's also about human rights and about people in general. So that's why legitimacy and competence is so important here. Then when you design and develop the system, you do validation and testing, and basically you check things like transparency, security and privacy, interpretability and explanation, and so on. And during the operation, you need to have monitoring tools to make sure that the system works as intended, and their maintainability is very important to keep the system up to date. And then if it fails, maybe because you didn't thought about the risk, you can always try these things in sandboxes. You will have to do an algorithmic audit. So algorithmic audit only happens when you did some harm and you want to see how bad is the harm. And here it's important to have contestability and auditability. So a system can have a lot of auditability, then the algorithmic audit will be much easier. Now, very important, never audit an algorithm that is not legitimate. Why? Because you will be legitimizing the algorithm. So this is very important that you don't do this. And this sadly has happened in the past. And some people have legitimized the use of such systems. When it does harm, you cannot do anything. Basically, you need to go to court. So that's the problem. And one important tool that you can use on all these parts is red teaming. So red teaming for the risk impact assessment, red teaming for validation and testing, and of course, red teaming during the audit. Any questions so far? Because there are a lot of content here, because this is the motivation for the questions. Any comments? Questions? No? Okay. So let's go in the set of questions. So the first ones are legitimacy and competency questions. I already said what is this, but let's do the question. So the first thing, is your proposed system beneficial for society and nature? That should be easy. But in many cases, many systems are only beneficial for the owner of the system and to get rich. One important question is here, would you use your system? If your answer is not clearly yes, there's something wrong with your system. You know that there's some harm, but you don't prefer not to suffer it. And that's important because today there are many people suffering AI, and they're very few profiting from AI. One reason, for example, it might be a waste of resources. We already have this conversation in the news every day. This table is from the famous paper, Stochastic Parrots. That was the first paper that showed the potential harms of generative AI in 2021. This was before ChatGPT 3.5. And for this paper, Timothy Gebru and Meg Mitchell, the heads of the ethics of AI team in Google, were fired. One example, you can have a very small transformer. Transformer is the architecture, neural network architecture of all language models. This one is a very small case of 200 million parameters. Well, that's equivalent for training about 57 years of an average human life in carbon footprint. Now, also you can use a lot of electricity, but the real impact of the usage of the chatbots is really bad. So we're talking about billions of people using this every day. And we should also include not only language models, but here you can put Instagram, TikTok, and all these things. So we're wasting so much energy in things that are not necessarily productive. And the impact can be really bad. So this is what happened in the Netherlands at the beginning of 2021. This is something going on from 2013. 5 years later, 4 NGOs sued the Dutch government because there was a system that accused 26,000 families of committing fraud in childcare benefits. 42% of them were immigrants. So if you were an immigrant, you were cheating. And finally, a court declared this illegal just before the pandemic. And the government had to compensate many, many families, although some of them already had left Netherlands. And after an analysis of the Dutch parliament, January 15, 2021, the whole government resigned. I don't know if you can read it. This is Mark Rutte, at the time Prime Minister of Netherlands. Today, he's in charge of the NATO. So he was not, his government was not punished by this judicial mistake. But this can be worse. I was using the Dutch case as the worst political outcome of a bad system, but in Australia, they managed to improve it. It's called robo-debt, which is a very bad name in Spanish because robo means steal. So it's like you're robbing people. And this was a system that tried to save welfare money to the government. So similar to the Dutch system that was trying to save subsidies, they have an ethical issue because you should start looking for fraud to enrich people, not in poor people. Poor people will suffer more if you make a mistake. And this system basically predicted and asked almost 500,000 persons to return money that they had received too much. Basically, they had lied in their information to the government. Most of these were false, and then the people did a class action, and until today, they're paying more than $2 billion to compensate these people. So the government wanted to spend less money, at the end spending more money because of this huge mistake. So that's the first question. The second question, does your solution rely on a proven scientific fact? I mean, are you doing pseudoscience or not? Or at least a reasonable hypothesis. You cannot prove it, but you have an hypothesis that there's a connection, a causal connection between something and something. So this is not true in many applications, and one is basically using physiognomy. People using your face to predict criminality. People using your face to predict your sexual orientation. People using your face to predict your political orientation. For example, this system, the same psychologist in Stanford, Kosinski, can predict 70% accuracy what is your political orientation. But in the US, that's easy. There are only two parties, and probably if I use a beard or long hair, I'm a Democrat. All these are stereotypes. So there are many, many spurious correlations that work very well, and you get a reasonable between quotes prediction, because 70% is not that large. It's not far from random. So this is the problem. And this is similar to phrenology, another pseudoscience that said that criminals had different convolutions on the brain. This was an idea of a German doctor at the end of 19th century. And there are other similar things. For example, there are also, this is what's called categorical thinking. So we invent categories that don't exist. Like, for example, economic categories. Like we divide people by salary, and we say, okay, anyone earning more than 2,000 euros is in this class. But €1 less is a different class, which doesn't make any sense. And we are using this idea again in the regulation for the use of AI. So we'll get back to this, because it's a typical cognitive bias to invent categories that don't exist. Race is another one. Skin color is a continuous variable. It doesn't make any sense to say where dark skin starts and light skin begins. And then another example is using data from other people to predict your behavior. So no one has proved that that works. It may work 80% of the time, but that doesn't mean it works for all people. Every people is different. So imagine that works 80% of the time, and 10% of the time you discriminate someone, and the other 10% of the time you favor someone. Yes, humans make mistakes, but in this case, we're doing mistakes by design. Whenever we decide to use AI, we are doing mistakes by design. For example, we will favor 10% of the time, we will discriminate 10% of the time, and the rest will be fine. Banks are using this every day. Insurance companies are using this every day. So this is a problem. It's already there. Third thing, I mentioned this, administrative competency. Are you authorized to solve the problem at hand? Let me give you an example of GDPR. South of France, near where Magnus is. In the end of 2020, on the end of 2019, two high schools in south of France decided to put cameras and doing facial recognition for the students just for security reasons. Well, some parents were not happy. They thought that they were discriminating some people, and they went to court, and the court said that this was illegal for 3 reasons, and these are very important. First, they didn't have the competence to do it. Basically, the directors of the high school didn't have the right to decide. This only was a decision for the mayor of the city. The second is also interesting, because you are doing it in a public space. According to GDPR, you need to have informed consent. And there was no informed consent. It's very hard to get informed consent in a public space. In the US, you get it by a sign saying, a smile, you are being recorded. But of course, that's not informed consent. It's just transparency. And finally, very important point too, the system was not proportional to the problem. Like if you want to have security, put a person in the door, a guard, you don't need to do facial recognition. Now, remember the Dutch case? I will read here the small letter, maybe you cannot read it, but says, this is the This is the chief of the position. He resigned one day before the government, but the position was asking for accountability. And why he resigned? Because he said, yes, I was Minister of Social Affairs during the previous large crisis, and no, I did not know that the authority, the tax authority, started this unjust hunt on thousands of families. So let's give him the credit of the doubt, and he's saying the truth. So he didn't know what was happening in his ministry, and maybe the person that did the system also didn't have the competency to do it because was just an engineer inside the ministry. Question number 4. Do you have the right experts for the problem that you are trying to solve? If you're working on health, do you have great doctors? If you are working in education, do you have great educators? It's a legal system, you have great lawyers and so on. This is very important because sometimes computer scientists are answering problems that they are not experts on. So this was the first group of questions about the legitimacy and competency of the system. And now we get to the technical questions. So now we are implementing the system. I already mentioned this. Is your solution proportional to the problem being solved? Do we really need AI? Many problems are using AI where there's much better solutions there, but it's so simple to use a language model that covers any possible problem instead of trying to do a specific system that will be much better. So it's more expensive, and that's why they don't do it. Let me give you some examples. This is a very sad example from the Spanish police. A system to check if a person reporting a crime was telling the truth. So let's say someone steals your wallet, and then the police checks if you're saying the truth, which is completely also a bit unethical. But there were several issues in this system too. For example, instead of using the report as reported by the person, they used whatever they had. What was that? The report written by the police according to what the person said. So you are not even using the language of the person, you're using the language of the police. So this was a big technical mistake. Interesting, in Germany, they tried to do the same, but NGO immediately moved to go to court against that. Because basically, you cannot do this. I mean, you cannot use a machine to know if a person is lying or not. This is beyond AI expertise. But it's interesting that in Spain, they use it. In Germany, they oppose it right away. So this is also how different cultures adopt technology. So very important to remember, you need to do minimal data collection, and you need to store data the minimal possible time. This is part of GDPR. Number 6, have you checked for bias in the data? Let's say demographic bias, like gender, ethnic bias, age bias. In the optimization function of the model, very important. Sometimes the bias comes from the algorithm, not from the data. Or in the feedback loop between the system and its users. For example, all e-commerce has this type of feedback loop with biases. And then you get things like popularity bias, exposition bias, and so on. And are you at least not amplifying bias? So you are aware of the bias, and you make sure that you are not amplifying it. This is very easy to amplify a bias if you are not careful. So not only you need to mitigate, but also you need to make sure that you don't amplify it. Can be the optimization goal. Let me give you an example. Deliveroo. This is a case that happened end of the 2020. A lot of people use this company, delivery company, to ask for food at night because of the pandemic. And there was a group of riders that earned much less money than another group of riders. They couldn't know why was that happening. So they were not all women, not all immigrants, not all dark skin. So, but they were earning less money. So they sued the company, and the company found out this much earlier, but didn't tell the judge. The solution was easy. And then at the end, the court said that they were discriminating people, and they had to pay a small fine. and also change the algorithm to make things better. So what was the problem? The algorithm never considered labor loss. So for example, if a person didn't work 1 week, that person was punished and received less work the next week. And then that caused that people that couldn't work for some reason, then they were earning less money. But maybe the reason was legal, like you were ill, or you are a woman that doesn't want to write at night because of security reasons, and it's completely legal not to work at night. The same with people with children and so on. So at the end, it was very easy. Include labor laws in the system, and then the system will be much more fair. This is obvious after you know it, but people forget about obvious things when they design systems. Number 7, are you tailoring the operation of your model to your problem? So basically, it's like a model looking for a problem rather than a model solving a problem. Are you using arbitrary thresholds? Many people forget about all the thresholds that AI systems have, and they keep the default values. For example, typical default value in a classifier would be 0.5, or a typical temperature in a language model, and so on. Are you using categories that are hard to justify? I already mentioned this categorical bias. All errors have the same impact, because if you're using accuracy, you are not analyzing what happens when it doesn't work. And the truth is that errors are all different. It's very hard to have a problem where all errors have the same impact. So you need to look at what happens when it doesn't work. And then that means to use a different kind of evaluation. This is part of my research because people is not doing this kind of evaluation. So let me explain this because I think this is very important. Because there's something I call non-human errors, which is an unknown failure mode, which makes these systems more dangerous when that happens. So let's say this is the problem space, the one in yellow. This is the problem you are going to solve. Now, this is the data you get from this space. So the data covers like half of the problem space. Depending on the problem, this data could be a very bad proxy for the problem. For example, if you are dealing with people, typically this is the case. You don't have a good coverage because people is hard to represent. People is really diverse, and there are too many factors in people. Now, let's say the blue circle is the training data, and from the training data, you build the machine learning model. Of course, it's a lot of data. For example, humans, when solving a problem, let's say this is a human solving a problem, the same problem of the machine learning, they use much less data. Maybe they use some data that the machine learning model doesn't have. And also the human is using things that are not in data: intuition, wisdom, guts, whatever you use when you solve a problem. So typically, humans and machines are using different input to solve a problem. And then they do different mistakes. So let's look the solution space now. So let's say that these are human answers, and these are the predictions from machine learning. Now, these two circles are really very close. They're much more similar, but I'm putting them apart just to show the different areas. Let's say that everything above the red line is a correct answer, and everything below the red line is a wrong answer. Okay? So what I really worried is about this region, what I call non-human errors. These are errors that machine learning does that the person will never do, that for us are completely uncommon sense. There are a lot of people without common sense, but still these are things that people will never do. And let me give you some examples. This is the first woman that died crossing a road in Arizona in a bicycle because she crossed at night in the wrong place. And this self-driving car by Uber didn't detect the bicycle and crashed her. This woman did everything we do in every large city many times. We want to cross the street, we look to the right, we see a car coming, and we say, we don't have enough time, but if I rush, I will be safe. Why? Because there's a human driver there, and the driver will not try to kill me, right? Well, this is what surely the woman thought, But the problem that this car didn't change the speed, kept at the same speed and crashed her because there was no driver, no human driver there. And this is for me a non-human error because a human driver will have slowed down and will not kill the woman. Then we have the third group of questions. These are responsibility questions. What happens after you make a mistake? 8, is your solution secure, safe, private, and it does comply with all legal regulations? This is something like you need to ask at the beginning too, but just in case, I make sure that you have it here. And here, the main thing is the EU AI Act that started in 2021 and finally was approved in August 2024. So a bit less than 2 years ago. Most of the important things had to start this year, but still we don't know because there's a lot of lobby not to put it, enforce it completely. Now, this regulation, it uses high and low risk systems. And this is already a problem. But first, we have another problem. Should we regulate the use of technology? This is like regulating the use of a hammer. We have never done it. We usually regulate problems like food, like transportation, like medicine, and so on. And these are arbitrary categories. Where is the border between low risk and high risk? Risk is a continuous variable. We don't even know how to measure it yet. We don't even know what is the harm that a system can cause. So this is very hard to do it properly. And also we have what I call a non-AI loophole. Why it should be only for AI? I showed you the example of Australia, maybe the example of the Netherlands. You don't need AI to hurt people. In fact, there was another case, much more clear that you need AI. It happened in 2024 in the UK. It was a problem that was going on for more than 20 years, the Horizon problem. Basically, the post office accusing small subcontractors in small towns of cheating. And finally, Mr. Bates, here is Toby Jones, went against the post office, so decided to go against a major company in the UK, and finally they found them innocent. The solution was much more simple. The system had a data corruption problem. And although many people claim that they were innocent, thousands of people, 4 committed suicide because they couldn't get the stress of the social injustice, and also people that went to prison, finally the court found out that basically it was just data corruption. And they're still compensating these people because this affected more than 3,000 families, and hundreds went to prison, and hundreds also pay money back that they really didn't take. So very important. We need to regulate the use of any automated system if you want to do that. Question number 9. Are your users fully aware of the impact of your system on their lives? So how much transparency you have on the risk and possible harms? In many cases, very little. Do you need interpretability or explainability in your system? For example, if you want to use Article 22 of GDPR, then you need to have explainability. And if you want to have the system working as intended, you need to have also interpretability. This is what happens in the Article 22, that you have the right to contest the decision. And here I interpret this Article 22. So basically, if you want to inform about the processing, so transparency, you need interpretability. So you need to understand what the system does from the beginning, the data, until you get the answer. And also you may need to explain in the case of contesting the decision. And you will need to have continuous validation, testing, and maintenance if you want to keep having a system working as intended. Very, very important. In some cases, explanations can be very dangerous. For example, in healthcare. I don't know how many people here used to see the Dr. House series. You know, this crazy doctor that had to find out what was the worst case of a possible symptom. Well, AI will give you the 3 top most probable causes, but AI cannot do what Dr. House does, because this is the problem. I mean, if you give the wrong explanation in health, that could be very dangerous. So maybe you give it 70% of the time right and 30% of the time wrong. That's not a good doctor. And the last one, do you have in place systems to allow contestability and auditability? Same for accountability. These are the 3 things you need to care to be responsible at the end. And you need to be aware of human incompetence here. And as George Box said, all models are wrong, but some are useful. This is the truth today. All models are wrong. These are models. That's why they're called models. But some are useful. And maybe you have seen this many cases, like lawyers using ChatGPT and basically having data that is not correct. Today, more than 20 courts in the US have special regulations on how to use generative AI in their court. And if lawyers don't follow it, basically they will lose not only the case, they will lose their license, because judges are really mad at lawyers using this system and basically having mistakes. But generative AI added more problems, more misinformation, more bias and hate, implicit and unknown and censorship, decreased diversity, only 200 languages are supported. And then what we are doing is we are increasing the digital gap because we have 10% of the people that cannot use these tools because of the language, 26% of the people don't have internet, 20% of the people are too young, a few percentage are too old, and if you take all this and do the right overlaps, you will see that half of the planet cannot use these tools, so we are not democratizing anything. We are increasing the digital gap. And at the same time, we are doing cultural colonization. So, Karin, how many continents there are? You are muted. I hope some people know a little bit of geography. How many continents there are?
7, I think.
7. So you are colonized. I'm sorry. How many flags? How many circles are in the Olympic flag?
5.
5. Okay. Why? Because Antarctic doesn't compete in the Olympics.
No.
So according to Europe, there are only 6 continents. But if you say 7, it's because you are already colonized by the US. I'm sorry. Because they split America in 2 because they are American. So very weird geography. So this is a small example. There are many other colonizations going on in culture, and they're related to gender, they're related to sex, they're related to guns, they're related to many other things that where maybe we disagree, but you would like to have all the views of a problem, not a single view. And we are losing cognitive skills. This is sad, but I see people that now they're not able to think. And this is even worse if you're using AI when you're a teenager, because that's the age where you learn to do critical thinking. And we have mental health issues. We already have more than 35 people that have died because of, with the help of chatbots, either murder, mass attacks, or suicides. So I'm not worried about artificial intelligence. I'm worried about our own intelligence. And then I will do something like I usually say we shouldn't do. I will humanize this robot to provoke you. So thank you.
Thank you.
Thank you so much, Ricardo. This was great.